eSilicon chips often are not chips at all. They're actually systems in package. We focus on several markets, including data center, artificial intelligence, networking, and 5G infrastructure. We're doing something for the first time in almost every one of these chips, and that is part of the challenge and part of the excitement. What we are doing is physically impossible to do without simulation. Without these tools, it would be impossible to build these chips. We're building chips for the folks who are building high-end routers. We're building chips for folks that are building hyperscale data centers. We're working on chips with customers today that are being deployed and are in trials in large cities around the world that are verifying the capability and the robustness of the 5G network that we believe will change the world.
Simulation is integral to this type of design process. If you were wrong, these issues would manifest as signal integrity, bit error issues, or power issues that also manifest as other functional issues that are very, very difficult to troubleshoot.
We found that ANSYS has a suite of tools that is focused on this problem. And that was really what drew us to the technology and drew us to the company, is that we felt we could get the right kind of analysis and accuracy to try and tackle this problem. It's very difficult. Our customers are using the most advanced silicon technology. If the chip isn't doing something absolutely new and different, it doesn't really cut it in the marketplace. And it creates some very interesting challenges to build those kind of chips and deliver them.
Red Hawk is the industry standard for power integrity extractions at the die level, and these tools allow you to run system level analysis. We want to make sure that the capacitors we place on the package substrate are actually effective in the bandwidths that they care about. From a time domain perspective, we run transient simulations that verify that final noise coming out of that entire system.
When we book a deal with a high-end customer for one of these rather sophisticated ASIC designs, it can take a year or more to build that chip.
This is why it's important to run the overall system level simulations. We're trying to work in a very confined region where we don't have very much space. And you can use that space to maximize the signal integrity performance or maximize the power integrity performance, the power delivery.
Everybody's invested multiple years and lots of money in this design. So these tools help to unlock these large ASIC deals, and that's the revenue driver for eSilicon. It's not just highly accurate tools that are well integrated for chip package system design. Of course, that's important. But it's also the attitude that the development team at ANSYS really cares how we use the tools, and there's an open communication path so that we can make it better together.
A lot of these things you can't measure easily, so we make a lot of adjustments and optimizations that require the usage of simulation.
Only when all of those problems are solved can you really deliver that chip into the end system with the performance that was expected. And that's success. That's when we win, that's when our supply chain partners win, and that's when our customer wins.